Hello guys, welcome back to the YouTube channel for embedded Rust programming on RISC-V. And in the last video I discussed about the digital I/O layer which I introduced as a HAL layer for GPIO. And in this I'm just gonna discuss briefly about the serial driver which I'm developing. So that like the digital I/O layer for GPIO, the serial driver would be an abstraction layer as well as a driver for UART. So as I said before, the main objective for these digital I/O and the serial.rs file is that any application binary or any application don't have to change the interface if there is a change in the hardware below. So I think if you go to the GitHub repository and go to the development branch, you can see so this has two binaries. One is the print.rs or the print binary, and the other one is the LED blink binary. And there is a library, a lib.rs file, and that lib.rs has, if you go to the source, and lib.rs would have the modules GIO and serial, and these serial HAL would in turn call the FE310 specific hardware interface. Okay, so how this FE310 file is imported is like this, and it's the same how I did for GPIO. Okay, so if you see the, let's go to the code. So when I switch between the Visual Studio and the browser, it's all the same, except that in Visual Studio you see that font size bigger, and it's easy to read. So this is the print binary, which would in turn make calls to the DIO, which is the digital I/O library, to configure certain GPIO pins as IOF functions. Because for example, this pin 17 GPIO pins, GPIO pin 17 can be either configured as in GPIO, or it can be used as a UART 0TX pin. So very first, this application just sets the pin as IOF function, and then it configures the UART and enables the UART, and just transmits maybe 10 times welcome, and this is new line and carrier feed. Okay, so one thing I realized in Rust is that in C a char would be always 1 byte, so I can basically just create a char array and just put this characters in single quotes. But whereas in Rust the char is 4 bytes, so that's why I mentioned here is not a single byte in Rust. However, a few or most of the ASCII characters can be made as a U8 with the suffix before, and I have also stored that into an U8 array. Okay, and I'm sure that everyone would have been aware that if you want to transmit data to UART, mostly it would be an byte or 8 bits is very common. So even in FE310, these UART supports only 8N1, that is like 8 bits, no parity, 1 or 2 stop bits. Okay. Now going back to the print application. So that's the code pretty much, and this is the serial driver. If you see this, I can enhance this further, and I can also make it as a proper serial driver with enough buffer and enqueuing options, so and so. But if you see, none of the code is or the interface don't depend on any of the hardware specific functions, but inside these interface the hardware specific functions are called. Okay, so any change below, if I switch to another chipset, then the only change in this would be this function, the lower level function. So there is no need for any change in the signature here. Okay, and I have also used trait for the first time, and this is a very interesting way of writing code in Rust. There are many YouTube channels who talk about generally about traits and how to implement. So basically this trait is nothing but creating a common if there is a set of functions which needs to be duplicated across, for example, the serial driver, it can be used on top of UART, or maybe tomorrow SPI, and maybe I2C. So all this would have these three functions like configure, enable, disable, do, send, byte, or so and so. So in that case, this trait is very handy. And if you see here, so this common interfaces across these serial devices can be written, then you can implement these functions for every serial device. Like for example, implement configure for UART, do, send, byte for UART. If you introduce a SPI device, then all you have to do is just configure for SPI and configure for do, send, byte for SPI, and then you can import these traits into the applications by use, like use crate. Serial is the library name which I have said, and then whatever the traits name, you can just import it here. Okay, and you can invoke the methods like before. If they taken the self parameter, then those can be invoked as methods here. Okay, now let's see if how this works. So I'll just connect my board, and I also want to mention you that I see if I make a release build instead of a debug build, then I see that this delay function gets optimized out. And also if I go to the UART, at some places those sticky bits, for example, okay, I changed it to volatile. Okay, so I didn't test it with the release build. I have just tested with the debug build. So let's see. Print is the binary. Localhost 1. So this is the serial port which is connected to the board. Let me connect. And as I mentioned, this application, all it does is just send welcome, maybe how many times, 10 times, and there's a delay to flush the UART FE4 before it gets disabled. Okay, and let's run this. So that's it. So on the left side you see the in text, and the right side you see hex values. Okay, so that's pretty much about it. And the latest code I have committed into Git, as well as it's available in the crate. So sorry, in the crates.io. So feel free to go through, and if you have any comments, please mention it on the comments. And if you like this video, please go ahead and press the like button. Okay, thank you very much, and see you in the next session.